Would it rationalize our denominator? Let's see. Okay, so just to repeat real quick, since I forgot to record before, we did the leg of this triangle over the leg of our triangle from geometry class, which is 1, and then equals the hypotenuse of this triangle over the hypotenuse of the triangle we learned in geometry class. And so now we're rationalizing our denominator. So we're going to multiply by root 2 over root 2. And the magic of this is that the root 2 times root 2 is root 2 squared. And what happens with squaring and square root? So it's just 2, right? So we did rationalize our denominator. And on the top now that we have the radical, honestly, I don't know why mathematicians love having the radical on the top better than on the bottom, but this is allowed and the other's not. Am I done simplifying? Is this as simple as it can be? Divide, right. And what do we get?
Actually, I'm not sure. Is it
7 thing 2? 7 root 2?
7 root 2?
All right, who thinks that the answer might be 7 root 2? All right, you have about half the class agreeing with you. And you are all right. It is 7 root 2. You don't want to divide 2 times because we're dividing this whole term by 2. Dividing it twice would actually be dividing by 4. All right, so if x equals 7 root 2, what does y equal? 7 root 2, because it is an isosceles triangle, because 45, 45, 90. Same angles means we also have the same sides. So 7 root 2 and 7 root 2. All right. Next one, our special triangle from geometry class has sides of 1, 2, and root 3. I'm going to get the x side first because it's easier. The short leg is in a ratio with 1, so that's easier. So I'm going to say x over 1 equals 20 over 2. See how much easier it is to get the short leg than the long leg because you don't have that root? X over 1 is just x. 20 over 2 is what? It's 10, Miss Burrell. You're right. All right. The y value is just the short leg times root 3. So the y is just going to be 10 root 3. You could set up a ratio if you wanted to, but you don't have to because it's just the short leg times root 3. All right. So that's just the background knowledge that's going to help you make some sense of the unit circle. Okay. Any questions before we move on to our new notes? Okay, can I move on?
Yep.
The unit circle. All right, the unit circle is the basis of trigonometry in like a pre-calculus class. It's kind of what comes after right triangle and non-right triangle trigonometry that you might learn in a geometry class or in IB-Apps. So the unit circle is a circle with a radius of 1 unit. That's why it's called the unit circle, because the radius is 1 unit. So notice there's a 1. It's kind of a weird 1. This is the number 1 on our radius right here of the circle. Okay, and trig values on the unit circle, we'll talk about exactly what they're saying there, but they're defined this way. Here's your angle theta, right? The opposite here is the y value of this point. You see that point? It has an x value and it has a y value. The opposite is the y. This adjacent right here, that's the x. Let's see if I can turn off another light. No? Can you guys see? Okay. All right, so we labeled x and y there. So here's my theta. We know sine is opposite over hypotenuse, so opposite is y and hypotenuse is 1. So opposite over hypotenuse, which is just the y. So when you're looking at a point on the unit circle, it's referencing this angle between the positive x-axis and this radius right here. We're talking about this angle in here. And this angle will have a sine that corresponds to the y value of the point. The cosine is the adjacent over the hypotenuse, so the adjacent is x, and the hypotenuse is 1, so that's just x. And tangent is opposite over adjacent, so it will be y over x. So often students will memorize the unit circle, and in theory, you should memorize the unit circle for your quiz, but because you have your calculator, it kind of backs you up a little bit. It's like not 100% going to give you everything you need, but it gives you most of what you need, okay? It's not a bad idea to memorize the unit circle. So the unit circle, once you memorize it, it tells you the sine and the cosine and the tangent of any angle that's on that unit circle. So you're kind of like walking around, you're like a human trig calculator. The coordinates of P can be written as, well, instead of x, we can write cosine theta. And instead of y, we can write sine theta. So if you know the coordinates of a point on the circle, you know the cosine of that angle and you know the sine of that angle. All right, take a moment to process that. Let me know what questions you have. We're going to talk about 3 more trig functions next. Okay. So there are 3 more trig functions after sine, cosine, and tangent. They are the reciprocals of sine, cosine, and tangent. They don't really add much to the story, except that sometimes instead of asking you the sine of 30 degrees, I might ask you the cosecant of 30 degrees. And all you have to do is find the sine and then find this reciprocal. It's not hard, okay? People confuse the cosecant with the inverse sine a lot. Don't do that. They're totally different things. Cosecant will find you a side, just like sine or cosine or tangent will find you a side. Inverse sine finds you an angle, so it's a totally different thing. All right? Cosecant, secant, and cotangent, they are simply the reciprocals of sine, cosine, and tangent. That's it. So then, if you know sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent instead of adjacent over hypotenuse. So you can see, these are just the definitions of them. Do get to know the words so that you're not trying to say sec and cot. All right, say the whole word. All right, on the unit circle, the reciprocal trigonometric functions at theta are defined this way. So since cosecant is the reciprocal of sine and sine is y, it's just 1 over y. Since secant is the reciprocal of cosine and cosine is x, it's just 1 over x. These are reciprocals. And then for cotangent, the reciprocal of tangent is x over y. All right, so those are definitions that we'll be using a little bit later in class. We're going to talk about how to build the triangle, the circle, the unit circle. And what I want you to start with is what we did last class. I want you to fill in the angles, see how much you can fill in from memory, and then do the rest. On the next page. Good question. So here's an example, okay? On this one, you have 0 radians, 0 degrees, 2 pi radians, 360 degrees. All the other ones, you can see that there's a degree mark where the degrees go, and then right next to it, that's where the radians go, okay? Don't put anything in the parentheses yet. That's what we're going to learn. That's the new part. All right, so first of all, I assume the degrees are a little easier for you than the radians, yes?
100%.
Yeah, because you're just used to thinking in degrees for now. And so you do need to remember that you start on the positive x-axis. So you start over here. That's your 0. Oh, I'm frozen. That's your 0 over here. And then you know this is 90 degrees because you know what a right angle looks like. So you just have to remember, like, 45 is half of that, and then the 30 and the 60, this is going to be a third, and that's like 2/3. Yeah, kind of. All right, then for the radians, does anybody have a way that like helps them remember where the radians go? Did you have something, Maddie? Did you have a way that you remember them? Is it easy for anybody to remember the radians? Does anybody think they already have them down? Jessica.
Should I say the way I do?
Yeah, go for it. Do you want to go up there and point? Okay. Guys, listen up. I want to hear how Jessica thinks of the radians, and then if somebody has something different to share, you can share too. Go ahead.
So I just do this side, like, this side's just all memorization. And then this side is like, I think of it as like a -1. So I just like write all the bottom numbers, and then it's like 3 minus 1 is 2, so it makes it on top.
I see that right
1
here.
minus 1 is 3. 6 minus 1 is 5. And this one's just like +1, so 6 plus 1 is 7. Then say for all of them. And then this one, you like multiply the bottom number and then subtract by 1. So like 3 times 2 is 6 minus 1, 5.
Mhm.
And then you do that all the way up. And then like, now where you put them is like the 3's have to touch. And then like the 6's, and then like the 3's, and then like the 6's. So they just touch each other. And then you have the whole like thing.
Thank you.
But yeah.
All right. Very good. Does anybody have a different way that you think about it that helps you make sense of it? Okay. We have like a few more days left in this unit to try to make sense of where those angles go. They are literally fractions of 2 pi. So the whole circle is 2 pi, right? The half circle is pi, and then you're just doing fractions. But everything that Jessica said made mathematical sense too. Okay? All right, so now we're going to talk about the points. The points come from your special triangles. So in geometry class, you learned the 1, 2, root 3 triangle. I'm going to show you on the board how they kind of adjust the 1, 2, root 3 triangle. You want the hypotenuse of the triangle, which is going to be the radius, you want that to be 1 because this is the unit circle. In the unit circle, the radius is 1. So to get to my hypotenuse from 2 to 1, I have to divide all the sides by 2. So 2 divided by 2 gives me a hypotenuse of 1. 1 divided by 2 gives me a 1/2. And root 3 divided by 2 gives me root 3 over 2. I'm going to use that triangle to find coordinates in my circle. While I'm up here, you guys ready?
Yep.
While I'm up here, I'm going to talk about the 45, 45, 90 triangle as well. I need the hypotenuse to be 1, so I'm going to divide by root 2. If I divide root 2 by root 2, now I have a hypotenuse of 1. The sides become 1 over root 2, but I need to rationalize that denominator. So just like in the warm-up, we're going to rationalize by multiplying the fraction by root 2 over root 2. So I multiply root 2 over root 2, and this side is root 2 over 2. Root 2 over root 2, and I get 2 over 2. Now, these numbers might not seem the friendliest numbers, but all the way around the circle, the only numbers you're going to see are 0 and 1 and these numbers, and that's it. Okay? So it's not like you have to memorize a lot of different numbers. I'm going to write our new triangles on the notes, so I'm going to write them up here. So we have our 30, 60, 90 triangle. (30, 60, 90), and the sides are 1/2, 1, and root 3 over 2. And then I have my 45, 45, 90 triangle. And those sides were root 2 over 2, root 2 over 2, and 1. So those are the triangles that we're going to use to build our circle. If you haven't written them yet, let me just give you a little zoom so you can see them a little bit better. Root 3 over 2, 1/2, and 1. Root 2 over 2, root 2 over 2, and 1. All right. When I talk about the coordinates of this exact point, this is the point where I make a 30-degree angle with my positive x-axis. So my 30-degree angle is right here, down here. I'm going to draw the triangle in. The problem with drawing the triangle is that if you start drawing the triangles and you just decide you're going to draw them all, like your circle's a mess because there's so many triangles in it. But here's one of them. So I'm drawing in the right triangle. The x-coordinate of my point is the long leg of the triangle. So to get to this point, my x-coordinate will be √3/2. My y-coordinate will be 1/2. That goes right here. √3/2, comma, 1/2. For 45 degrees, you could draw that triangle too. But like I told you, the more triangles you draw, the bigger a mess your circle is going to become. But here's my other triangle. I'm drawing it in pink here. Okay, that's my 45, 45, 90 triangle. The x-coordinate is √2/2, and the y-coordinate is also √2/2. Okay, I'm going to stop drawing triangles, but you have to believe me that there's also a triangle at this point. It's going to connect down, and it's going to make that 30, 60, 90 triangle. It's just turned on its side. So if I have a triangle right here, now the x-coordinate is my short leg, and the y-coordinate is my long leg. So the short leg comes first, the 1/2, and then the long leg, the √3/2. They did just flip, that's right. All right, up here, remember this is the unit circle. The radius of the circle is 1. So which part of the coordinate will be 1, the x or the y? Tell your neighbor, which part of the coordinate will be 1, the x or the y? Yeah. It's the y. The y is 1, the x is 0. All right. We just did the hard part. The easy part comes next. Everything else you can figure out by just reflecting across the axes. So for example, this one right here, it has the same height as this point. So the height of the point is √3/2. But instead of going right 1/2, I went left 1/2, so it's -1/2. I want you to take a moment now to see if you can reason out the coordinates of the other points based on the ones we have. Okay, so I haven't quite finished yet, but I'm going to talk you through the last part just so you don't have to listen to me talk about all of them. So in quadrant 2, all your x's should be negative and your y should be positive. So you should have a negative number, comma, positive number. Down here, both x and y are negative, right? Negative, comma, negative. And then in the fourth quadrant, which one's negative? Just the y. Okay, now make sure your reflections are done correctly. This one reflects from this point. So this would be 1/2 and then -√3/2. This one is the middle one, and so kind of lost my negative there. So √2/2, -√2/2. And then here, √3/2, -1/2. And finally up here, 1, 0. All right, now, the power of the unit circle is that we know that the cosine is your x value and the sine is your y value, right? So now, if somebody asked you all of a sudden, hey, tell me the cosine of 135 degrees, you would say what? The cosine of 135 degrees, you go to that unit circle, and you find, which one is it? Is cosine the x or the y? It's the x. and say, oh yeah, the cosine of 135 degrees, I don't even need a calculator. That's negative root 2 over 2. Okay? So you could be asked the sine, the cosine, the tangent, the cosecant, the secant, or the cotangent of any angle on the circle and be expected to pull that out of your brain. Now, remember I told you there's not that many answers. So if, for example, you get confused and you're like, oh shoot, I can't remember if that's root 3 over 2 or 1/2, you can also then type cosine 135 in your calculator. It will give you a decimal, which will be the same decimal that you would get for either 1/2 or root 3 over 2, right? So there's a lot of checking you can do since you have access to your calculator, but in general, you should have an idea of what these answers are because we won't take the decimal as the answer. We still will expect it to be 1/2, root 3 over 2, root 2 over 2, whatever it would be. Okay, there's just not that many options to choose from. All right, so thinking about sine, cosine, and tangent, we know that every point is going to be cosine, comma, sine. Let me see, am I in the, nope, I'm not in the window. Every point's going to be cosine, comma, sine, right? The cosine's the x, the sine's the y. So if I ask you the sine or the cosine of an angle in the first quadrant, will they be positive? Will they be negative? Will they be 0? If I'm in the first quadrant, the cosine will be what? Positive, and the sine will be positive. And the tangent, which is y over x, will also be positive. So in quadrant 1, all your trig values are positive. See positive trig values? There you go. In quadrant 1, all your trig values are positive. In quadrant 2, your y is positive, right? But your x is negative. So that means what trig values are negative? What corresponds with x? Cosine. So your cosine's negative, your sine is positive. What about tangent? Tangent is y over x. Will y over x be positive? Positive over negative. Does that give you positive? No. So not the tangent, but yes, the cosecant. Because remember, cosecant is just the reciprocal of sine. So the sine and the cosecant are going to be positive in quadrant. Sorry, I was looking at the wrong one. Sine is, wait, did I do that backwards? No, sine's the y. Yeah, so the y is positive here. And then in quadrant 3, the sine and the cosine are both negative. But what about y over x? Yeah, negative over negative makes positive. So the tangent and the cotangent are positive in the third quadrant. And then in the fourth quadrant, what's positive?
Cosine.
Just the cosine, thanks. And then it's reciprocal secant. Of course. All right, so on the next page, we're going to use this triangle to find the sine, the cosine, the tangent, etc. of some different angles. I still see people writing, so I'm going to wait. But feel free to get started on that, because if you look at sine 5 pi over 6, you're going to find 5 pi over 6 on your circle, and then you're going to find the y value, and that's your answer. That's just it. Okay? So sine 5 pi over 6, I go to the circle, 5 pi over 6, I find the y value, my answer is 1/2. That's it. Yep. Yep. All right, so please work on the problems on that page. All right, folks, I'm going to ask you to quiet down so I can help you check your work on these. Okay. All right, cosine pi over 3, you went to the pi over 3 and you chose the x value and it was 1/2. And that was very interesting that the sine of 5 pi over 6 is the same as the cosine of pi over 3. For the tangent of 4 pi over 3, you did y over x. So you did your y value over your x value. A lot of you were asking questions about fractions, which those are good questions to ask. So you had this. Oh, am I on freeze? Oh, I'm still on freeze. There we go. Okay. So for tangent 4 pi over 3, you had root 3 over 2 over negative 1 over 2. And so some people had questions about what to do with that, because if you use your calculator, it gives you a decimal, and that's not what we want. So you can, like mathematically, if you have a fraction and a fraction, you could multiply the numerator and denominator both by 2, which would cancel this 2 out. But I'm also okay with you seeing they're both over 2, and so you can just cancel those over 2's out. If you want to show the mathematics step, though, you can do times 2 times 2, and that will also cancel those out. So now I'm at root 3 over how did I get, they're both negative. Okay, so negative root 3 over negative 1, and then my negatives cancel out, and I just get root 3. Is that one okay? Okay, so just a couple reminders about fractions there. For the cotangent of 7 pi over 4, that should be the x over the y. And so the x was positive and the y was negative. All right, and you're dividing a number by its opposite. That's always going to give you what number? -1. And your calculator could have been helpful in that problem if you put parentheses in the right place, but you didn't need it because you know that a number divided by its opposite is -1. And I'm okay with you just showing me that much work. Like, that's as much as you need to show me. Okay, secant is 1 over the cosine, right? 1 over the cosine of pi. And the cosine of pi was -1, right? So 1 over -1, which is just -1. All right, and then some of you got to 9 pi over 4 and you said, wait a minute, that's not on the unit circle, right? Did anybody figure out what to do with 9 pi over 4? Go ahead, Sophie. Okay, Sophie subtracted 2 pi from it. Maddie, did you do the same thing? Did you also subtract 2 pi from it? I like it. Okay, so that I have a mathematical way to approach it, and I also have a geometric way to approach it. So this is very good. So let's start actually with Maddie's method of continuing to go around. So when we go 8 pi over 4, that's 2 pi. We end up back here again, right? 8 pi over 4. And so we went 8 pi over 4. We need to go another 1 pi over 4. So we're going to end up here again, right here at that 45 degrees pi over 4. All right, and that corresponds with Sophie's method, which was just subtract the 2 pi from it. So subtract that whole circle from it. You end up with pi over 4, and that puts you back at the same place too. Both of these methods work, okay? So this is the point we're talking about on the circle. And then what did we try to find? I already forgot. We're trying to find the cosecant, so that would be the reciprocal of the y value. So here's my y value here, right? I need its reciprocal. So 2 over root 2, and then I have to rationalize that. So I get 2 root 2 over 2. These cancel, and you just get root 2. Now, after a while of doing the reciprocal of 2 over root 2, you're going to know that it's root 2. And again, once you know that the reciprocal of root 2 over 2 is root 2, you can just go straight from this step to this step. All right. When you get to the second part, it says find the exact value of theta for the angles between 0 degrees and 360 degrees. That is cueing you into the fact they want the answers in degrees. And then for problem 3, they want the answers in radians. Okay? So they want all the angles that have a sine of 1/2. Raise your hand if you already had a chance to try section 2. Anybody do that section yet? Okay. So let me give you a minute to do this. You want all of the angles between 0 and 360 degrees that have a sine of 1/2, and then all that have a tangent of root 3 over 3. And then down here, you're going to do the same thing, but you're going to work in radians. I'm going to turn a light on because it just kind of got dark. And you guys keep working. All right, guys. I think we have another page to go, so I am going to start going over this, but I appreciate that you guys are trying to think it through. All right, so the sine is 1/2. We were looking on the circle to see where was the y value 1/2, and you found that there were two places, at 30 degrees and at 150 degrees. They both had a sine of 1/2, so you wrote down both angles, 30 degrees and 150 degrees. For the tangent of root 3 over 3, we were having some trouble, but we did check the tangent of 30 degrees, and over here, this is just like my thinking space. The tangent at 30 degrees was 1/2 over root 3 over 2. These canceled. We had 1 over root 3, and we rationalized it. And we got root 3 over 3. So this checks out. 30 degrees is right. Did anybody find the other angle? Looking at your circle. You still want the 1/2 on the top, and you want the root 3 over 2 on the bottom, right? But if they're both negative, those negatives can cancel out and give you the same answer. So this is the point we should be looking at, and that's going to be 210 degrees. All right, cosine theta is negative 1/2. So we're looking for where the x value is negative 1/2. So looking at the circle, you should have found 120 and 240. All right, secant theta is negative root 2. Secant is the reciprocal of which one? Secant's the reciprocal of which one, sine or cosine? Cosine. All right, so we're going to look for where the cosine is negative on the circle. The cosine is negative where the x is negative. So over here, if we had to guess which one would have a reciprocal of root 2, I would probably not guess this angle because that's a root 3, or this one because that's a root 3. I'm thinking it's probably 135 and 225, but we're going to check. The reciprocal of negative root 2 over 2. So my guess is 135 degrees and 255. I'm going to check it though. Maybe it's that. Reciprocal is going to be negative 2 over root 2. Rationalize. Negative 2 root 2 over 2 and cancel. And it does give me negative root 2, so that means my guess was right. So just a little bit of guess and check with that. All right, number 3, you're doing the same thing, but we're going to just name the angles and their radian measurements. So where the sine is 0, there were actually 3 answers. Did you find all 3 answers where the sine was 0? Look at your circle now. Where is the sine 0? Sine is the y value. So it could be 0 radians, or it could be what else? It could be pi radians, because it's 0 over here, or it could be 2 pi radians, right? 0 radians, 2 pi radians, or pi radians. They all have a y value of 0. Cotangent is root 3 over 3. This happens at pi over 3 and at 4 pi over 3. The cotangent is going to be positive in the first quadrant and the third quadrant. Positive over positive and negative over negative will give you positive. And if you divide them out, you will find that the angles that work there are pi over 3 and 4 pi over 3. All right, take a minute to find out where the tangent is 0. Tangent, remember, is y over x. Where's the tangent 0? Tangent is y over x, so where will the tangent be 0 on your circle? All right. Y over x, like give me an angle and we'll look at it and see if it's right. Just one angle. With a tangent of 0. It can be a right answer or a wrong answer. I don't care. Just give me an angle. All right, let's check 90. Thank you for suggesting one. So y over x, 1 over 0. Does that equal 0?
Yes.
It's hard to know. Try it on your calculator. What does your calculator say? 1 over 0. What's it say?
Divide by 0.
Yeah, because we're not allowed to divide by 0. So that was an excellent guess. What's another guess we should try? 0? Okay, let's look at 0. 0 over 1, does that equal 0?
Yes.
Okay, if you're not sure, you can check on your calculator. 0 over 1 does equal 0, so the tangent is 0 here. Where else? 0 radians works. What's the other radian measurement that might work?
180.
Over here, right? And so because we're answering in radians, we're going to say pi, but 0 over negative 1 is also 0. And then going back to the right side, we can also call this angle 2 pi. Same angle, but it has more than one name. So 0 radians, pi radians, and 2 pi radians, just like the first one. All right, here's a strategy for the last one. They're telling you the cosecant. The cosecant's not on the circle, so let's do its reciprocal and find its sine. So if this is the cosecant, then the sine theta would be negative 3 over 2 root 3. When you rationalize your denominator, you only have to rationalize the part that's in the radical. So we only have to multiply times root 3. Root 3, root 3. So the sine of theta is negative 3 root 3 over 2 times 3. And these 3's cancel. So the sine of theta is negative root 3 over 2. So we're going to look at your circle and find where the y values are negative root 3 over 2. And it looks like it's these two down here, negative root 3 over 2. So your answers are 4 pi over 3 and 5 pi over 3. Okay. Now, you can easily check answers like these on your calculator because you can type the sine of 4 pi over 3, and then you can type in negative 2 root 3 over 3 and see if you get the same decimal. So you can check these answers, but it is hard to do the whole problem on the calculator because of the fact that we're using all these radicals. All right, when you're ready, turn the page. We got one more page in these notes. Oh, there's 2 more pages in these notes. Wow. We're not going to finish them. Good news is the bell's going to ring and it's just going to ring, but we're going to do what we can in 10 minutes, okay? All right, let's stay focused here. All right. Some of this is repeated. It says the radius of the unit circle is 1 unit. The x value gives the value of which function, guys? We already learned this. Cosine theta, yep. The y value gives us sine theta. I'm not sure if that's supposed to say dividing. It says diving. As the origin is one of the endpoints, dividing the y-coordinate by the x-coordinate gives us the slope, which we call gradient in IB. So the gradient. So the gradient of the line, which would be the change in y over the change in x, that is also the tangent. So just be aware that if a problem tells you the gradient, it is also telling you the tangent of the line, of the angle. All right, so if you think about right triangle trigonometry, when you're inside of a right triangle, all the angles have to be less than 90 degrees, except for the right one, right? So we've never done the sine of like 120 degrees before. But it does have a sine value, and you can do that using the unit circle. So you're allowed to find the sine, the cosine, and the tangent for like any angle, like 1,000 degrees. It has a sine, cosine, and tangent, and you can find it by thinking about the unit circle. All right, the coordinates of a point on the unit circle to 3 sig figs are these numbers. So let's try to estimate where they are. So this is 1 unit here. This whole thing is 1 unit. So here's a half unit. So 0.629 is going to be a little bit more than the half, and then up here. So we're about there. Oh, you can't see. Sorry. I just estimated because this is 1 whole unit, so this is 1. And so 2 boxes would be a half, so I had to go more than a half. And so this point right here is 0.629, 0.777. I'm going to draw the triangle that connects to the origin and goes straight down. And draw that right angle in there. Okay, so if I know the x and the y, I also know the cosine and the sine of the angle. So if I want to find the angle, I could use inverse cosine, or I could use inverse sine. I have 2 options. In this one, actually I could even do inverse tangent. In this one, they did it all 3 ways. I'll show you what they mean by. You really have options. You don't have to do the problem 3 times, but it's good practice in case you weren't given all the information. So cosine theta is 0.629. How do you get rid of a cosine? What's the inverse of cosine? It's inverse cosine, right? The inverse of cosine is inverse cosine. So you apply the inverse cosine to the cosine, and you apply the inverse cosine to the 0.629, and then these cancel, and then you use your calculator to do inverse cosine 0.629. Before you press cosine, what do you have to press to get inverse cosine? Second. So go ahead and do that on your calculator. So clear that out, and I'm going to do second cosine 0.629. Oops, I did too many. I think I might be in the wrong mode. Let me check my mode. I know. I don't think I'm in the right mode. There's my mode button. Oh, yep, I'm in radian. Let me try degree. All right, 51.0 degrees. You guys getting that? All right, If I wanted to do the same problem with sine, I would do inverse sine of what number? The sine number, right? All right, try it and see if you get the same answer. You should, because it's the same angle. Inverse sine of the same answer. There we go. Do you guys still get 51.0 degrees? Yeah. And you can also do this problem with inverse tangent. So theta can also be inverse tangent of y over x. So 0.777 over 0.629. And if you do that, you should not be surprised to find out that the angle is still how many degrees? 51, yeah. Sorry, now it got bright again. No, we're going to do one more. One more. All right, looking at 6. Oh, we got 51.0. Given that one solution of cosine theta equals 0.6435 radians, find all the other solutions and give your answers to 3 sig figs. So the first question I have is 0.6435 more or less than pi? It's less, because pi is 3.14, right? How much is half pi about? Yeah, but how much in radians? It's about what number? Pi is 3.14, so it's about 1.5, right? A little bit more than 1.5. So this angle is also less than pi over 2, so it means it's in the first quadrant. Somewhere in the first quadrant here, okay? Has a cosine. Cosine theta is equal to 0.6435, right? What other quadrant has a positive cosine? A positive x value? 1, 2, 3, or 4? 4. So if we reflect this one down here, the cosine here is also going to be, cosine theta is going to be 0.6435. So between 0 and 2 pi, there exist 2 angles that have this cosine, okay? Then it's also going to negative 2 pi, and this is something that is brand new, but negative 2 pi is when your angle goes backwards. So for example, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So there are 4 answers to this problem. I can see you do not have the patience to listen to me explain them. So we're going to catch up on this next time, but feel free to try this, okay? Know that you also have a Delta Math that corresponds to this lesson, so that's something that you can get started on.